Dan Abbott. I'm making this short video for the print reading class to show you how to solve the 3060 triangle problem when using architectural units. Also showing you why the metric system is so nice. The first place for a 3060 triangle, it has a special characteristic, and that is that the hypotenuse C is equal to 2 times the shorter leg, the A leg in this case, and that's for a right triangle only. And this is one of the special triangles. There's a 3-4-5 triangle, there's a 45-45 triangle, and the 30-60 that have these kinds of special characteristics that allow you to use them to solve certain kinds of problems. So the basic problem here is this. We know that the length of something architecturally, maybe we're laying out, I don't know, maybe we're laying out raised bed gardens and we want to have an angle of 30 and 60 degrees, make sure that's 90 degrees in there. So what we're going to do is say we know that that distance as measured by a tape measure is 4 feet 2.5 inches. What I want to do is calculate the length of side A and the length of side C. In order to do that, we need to convert architectural units into decimal units so that we can do the conversion. So 4 feet 2.5 inches is the equivalent of, we could do this by going to inches or going to feet, so I'm just going to go to feet, 4 point some decimal amount of a foot. Well, that decimal amount is going to be based on 2.5 inches. So what we'd have to do is take 2.5 inches, and to convert it to feet, we have to divide by 12 inches, which is going to cancel out per foot. Now I know you know that, but I'm still requiring that you write down all your units and doing this so that you can keep track as they get more involved when we start dealing with areas and volumes. So if I take 2.5 and divide by 12, let me bring my calculator up. So 2.5 inches divided by 12 inches per foot equals 0.2083, and then a bunch of other threes as well. And what that means is we can write that 0.2083 feet, because that's what's left over. We take that decimal value and we add it to the 4. And we get 4.2083 feet. Now that value can be used in the place of what you have here as architectural units for doing these calculations. Now once we know that, we know what we're going to start with. We can take that value and we can put it into a formula, but the question is, what's the formula? Well, the formula is Pythagorean. The hypotenuse of a right triangle, in this case we're calling it C, squared, is equal to the square of each side added together. So it's going to be equal to A squared plus B squared. And this is simply a characteristic of all right triangles. It makes it very, very helpful in doing design in almost any field where right angles are important. Well, I only gave you one value here, which is 4 foot 2.5 inches. So how can you calculate both sides? Well, if we can find A, double A is going to give us C. And that also means we can write down the equivalent by saying if C is equal to 2 times A, then we can substitute 2 times A any place C arrives in this formula. We come back over here and we say 2A squared. I'm putting it in parentheses. Let me bring it up a little bit. I'm putting it in parentheses. Move that whole thing up. Putting it in parentheses so you recognize that it's not 2A squared, it's 2A squared. The difference being that that 2 has to also be squared in order to come up with the value. So the value in this case, when you do that, is 2 squared, which is 4, times A squared. So that is the equivalent of this. Put down the parentheses so you don't mistakenly think that this would result in 2A squared as opposed to 4. Now that you have 4A squared, go over here and say that equals A squared plus B squared. Well, we can subtract that value from this one. So we have 3A squared equals B squared. Now we only have two values, and that means we can substitute B for, substitute 4.2083 feet for B. So if we do that, back over here. We say 3a squared equals 4.2083 feet squared. So we're solving for a here. In order to do that, we're going to have to then square this value. And again, you're putting it in parentheses to recognize that that number gets squared and then the units get squared as well. So I'll bring back my calculator and I'll put 4.2083 squared, which is right there. And that's going to give me, clear that out of the way, here we go. That's going to give me 17.709, and we're going to be rounding to 4 decimal places and everything in this class, so that's going to become an 8. That's going to become an 8 because if you go to 4 decimal places, 709, 7's in the 4th decimal place, but just to the right of it is a number larger than 5, so we have to round that up. Feet squared. So 3 times a squared equals that value in feet squared as well. Anytime you have an equation, you can do the same thing to both sides. I'm dividing both sides of this equation by 3, which still makes it an equation. Dividing 3a by 3, 3a squared by 3 leaves us with a squared. Now I'm just going to use all the numbers here. I'm going to write it down by rounding. But as long as my calculator is giving me an even more accurate value, I'm just going to leave it there. Divide by 3. Come back out here, and now a squared is equal to 5.9033. Now, what are the units? Feet squared. Now what I want to do is find out what is a equal to. Well, if we take the square root of both sides, which you can do because it's an equation, you're going to say a is equal to, go back to the calculator, the square root of that value. The square root of that value equals 2.4297 feet. So now we've got the answer to a in decimal feet, but in order to be parallel, and anytime you have a problem like this, if you're given one value in feet and fractional inches, which is architectural units, the other values must also be in feet and fractional inches. So it is true that this value is 2.4297 feet, but that's not the right format, given the format we have here. We can double that number, though, and come over here, and we could do that right now. Let's go back to our calculator. So we'll take that value, multiply times 2, and again, I'm not rounding to 4 decimal places as I go, since the calculator is going to give me the value to a much more accurate level. So you might, if you do all that rounding, you might get a slightly different answer. You'll get something called a rounding error. But I'm going to go 4.8593. So 4.8593 feet's going right here. Now again, that's a decimal value. It's not the same format. So how do we find the same format? Well, I'm just going to go to a clean sheet of paper here. First, we know it's going to be 2 feet. We can write that in any of these systems. So we just write the 2 and you just write the 4. Now what we need to do is find out what is that value right there in inches. So what do we do to find that out? 0.4297 feet. How many inches are there in a foot? 12 inches per foot. You write down the units. We're going to multiply or divide. We're going to multiply to get rid of feet. Also, because it gives us a larger number. So if we multiply this value, and the value I'm looking for here, I'll go back and divide that by 2 again. So this is the number that I had. I'm going to multiply that value by 12, but I don't want to multiply it times the 2. The 2 is feet. We've already removed it because it's whole feet. So I'm going to subtract the 2 from this. That leaves me with decimal feet, How many inches does it represent? First, I'm going to guess, since it's less than 0.5, that it's probably less than 6 inches. So I'll multiply times 12, and I get a value that is less than 6 inches. And the value that I get is 5.15, well, 5595, and that 5 is a 5, so it's going to get rounded up. So 1.569 inches. Now, whole inches is going to go up here, dash 5. So now we've got the inches. So it's 2 feet 5 inches, and this is a little mark that kind of confusing, so let me get rid of it. That's just a leftover pencil mark from something else. So 2 feet 5 and some fractions of an inch. Now once we get rid of the 5, what does that decimal value represent in fractions of an inch? So we have to decide first how accurately the fraction has to reflect that value. I'll subtract the 5 from this number. There's the decimal value I need to worry about. Since for this class I've told you that everything that's fractional must be within the nearest 1/32, in this case inches, I'm going to take that value and I'm going to multiply it times 32 32 per inch. Those are my units. There are 32 32 in 1 inch. This value is in inches, so when I'm done I'll find out how many 30 there are in that value. Now I take that again, I'm just going to go out and make this as accurate as possible. I multiply that times 32 and I get 4.999 whatever. Now here's the thing, I can't have a decimal and a fraction mixed, so what I'm looking for is the nearest whole number. The nearest whole number is a 5. Since the nearest whole number is a 5, that value right there is the equivalent of 5/32 of an inch. That's the value within the nearest 32nd. So right up here, erase a little more of that. Right up here we're going to put 5/32 and then the inch mark, and that's how you would write that. Now you just have to double that value over here. You can double it from here. If you doubled that, it would be 10/32, which would be 5/16. Double that, it'll be 10, which is 10 inches. Double that, it'll be 4 feet. So we could say 4 feet 10 and 5/16 inches. So those would be the two values. And if you look at it then logically, A and B and C have the relationship that's necessary based on the Pythagorean theorem. And because it's a 30-60 triangle, it just so happens that A is 1/2 of C. So those are your right answers.